Good morning. This is our today's topic. Spooky action at a distance. Okay, you have found the name of the topic title in the thumbnail of this video. Spooky action at a distance. This is a famous phrase given by Einstein in 1935. Okay, and along with him, two more scientists were there, means physicists were there. They are Podolsky and Rosen. And popularly, this phenomenon was related to quantum entanglement. Quantum entanglement, this is a phenomenon you will find in the study of quantum physics. Okay, what is the topic? Quantum entanglement. There you will find this. Okay, and Albert Einstein, in 1935, along with these two scientists, Podolsky and Rosen, published a paper in 1935, and there he wrote this sentence: spooky action at a distance. Now, question is, what is quantum entanglement and why Einstein used such a phrase? Okay, what is quantum entanglement? In quantum mechanics, you'll find that two particles are correlated, two or more than two. There is a chance that more than two particles can also be involved. Okay, two or more particles are involved in such a way that state of one particle is dependent on the state of the other or others. Okay, state of one particle is dependent on the state of the other or others. If more than two particles are there, then others, that what will be there. So even they are separated by a vast distance. Here vast distance means the distance may be in terms of light years also. Yes, this is true. Experimentally, this was found to be true. First experiments were conducted by John Bell. He is also a physicist. John Bell conducted several experiments and he confirmed that yes, this is a real phenomenon. By using the theory of classical physics, you cannot explain such phenomenon. Okay. So first of all, what you should know, what is quantum entanglement? If two or more particles are separated by a vast distance, and if you are trying to measure the state of one particle, state means what? State means it may be spin, it may be polarization of the particle, it may be momentum of the particle. Okay. Whenever you are trying to measure the state of one particle, immediately you know the state of the other particle, whatever be the distance, whatever large be the distance between them. The distance may be in terms of light years also. Okay. And that's why Einstein used the phrase spooky action at a distance, because Einstein could not believe this phenomenon to be true. That's why he used that phrase. Okay, he could not believe. So I have noted down here 5 key points about quantum entanglement. First is instantaneous correlation. Yes, whatever be the distance between the two particles, if you change the state of one particle, immediately you will observe the change in the state of the other particle. It does not depend upon the distance between them. That means this phenomenon is instantaneous. Okay. Next point is non-local phenomenon. In classical physics, even in the theory of special theory of relativity or general theory of relativity of Einstein, both are Einstein's theory, special theory of relativity and general theory of relativity, you have found that cause and effect, okay, take some time. and that time the maximum speed is, it is the speed of the light. It is the speed of the light, and speed of the light, you know, it is limited. It is a fixed value. In vacuum, it is 3 lakh, not lakh, 3 into 10, 3 into 10 to the power 8 meter per second. You know the velocity. In terms of million, it is 0.3 million kilometer per second. 0.3 million, okay, kilometer per second. In India, lakh, this term is used. But in other countries, lakh, this term is not used. Anyway, you know the speed of light. So, we know that each and every phenomenon is local. It takes some time for the cause and effect. Okay, but in case of quantum entanglement, this does not take any time. It is instantaneous. That's why this point is there, non-local phenomenon. It is not local, it is, quantum entanglement is a non-local phenomenon. Okay. Then comes Einstein-Podolsky-Rosen. In the beginning of this lecture, I have already told you, this is popularly known as EPI. E for Einstein, P for Podolsky, and R for Rosen. These are the 3 names of 3 physicists. They are popular physicists. Okay. Since they could not believe, because they were thinking about classical physics, they were thinking about special theory of relativity, they were thinking about general theory of relativity. Those things were in their minds, okay, and that's why they could not believe such a phenomenon. So that's why they named the phenomenon to be a paradox, okay. Okay. Next comes quantum measurement. Quantum measurement, I have already mentioned this thing, that if you want to measure the state of one particle, okay, then here statements again, I want to mention the same thing, that is spin or polarization or momentum. Okay, spin, polarization, momentum, these are the measurement of states. When they are not measured, the particles remain in a state of superposition. When they are not measured, until they are not measured, the particles remain in a state of superposition. And as soon as state of any one particle is measured, there you will find collapse of the superposition. Okay, collapse of the superposition, and you will be able to immediately know the state of the other particle, whatever be the distance between the 2 particles. Okay, whatever be the distance. Just knowing state of one particle will give you the information about the other one. It does not depend upon the distance between them. So that is quantum measurement. Okay, that point implies that thing. And next, last point comes applications. Yes, it has already got practical applications. There are so many technologies. Okay, there are scientists have already developed so many technologies using this quantum entanglement phenomenon. Among which these are most famous: quantum computing, Q for quantum. Okay, in short I have written only Q. Q for quantum. Quantum computing, then comes quantum cryptography. Quantum cryptography, okay. Then comes quantum teleportation. So, and here I have written the technology term. You need not to watch the board, okay. Anyway, so this was all about the phrase. This is a popular phrase, okay, given by Einstein. Spooky action at a distance. Because Einstein and his collaborators, Podolsky and Rosen, they could not believe such a phenomenon at that time. Actually, Einstein could not believe the phenomena. There are so many phenomena of quantum mechanics. He could not believe all those things. Actually, there is no similarity in between Einstein's own theories, that is special theory of relativity, general theory of relativity, and quantum mechanics. Both are different things. Okay. And at the time of Einstein, the subject was in a state of development. It was just growing, that subject. Okay. Anyway, still there are so many mysteries in this subject. Okay. Anyway, this is the end of this lecture. Next, I'll try to create a few more videos on such topics. Subject is quantum mechanics. Okay, thank you. Thank you for watching this video.